Hey guys, I need to give you some notes over a two sample T interval. So turn to your page 10 of your notes, and as you turn to page 10 of your notes, you'll notice there's a bit of redundancy in them. So let's take the time now to do something I know you'll totally appreciate, and just cross that out, cross the two sections out. Because my question is, what is the formula for a two-sample T interval for the difference of two means? Now, as we can see here, we can refer to the brown sheet, but we're going to look at this. This is going to be the difference of your two means plus or minus T star, because remember this is a T test, times the square root of your variance, because remember variance is S squared, sub 1 over the sample size of the first group, your variance for the second group over the sample size of the second group. How do we do this in the calculator? As I slide down, here we are going to be using a two-sample t-test, which is your number two-sampled, I said the wrong thing, let me correct myself. A two-sample t interval, which is your number 0 on your TI 83s and 84s. Now, please recognize that an observed difference between these two sample means can reflect the actual difference of the parameter of the population. Like we've always said, we take the information about the sample and make a conjecture about the entire population. So what are our null hypotheses? Well, we already talked about this today. Here is your mu sub 1 minus your mu sub 2, or it could say that they equal each other. Here is information that we've already discussed today in class about a significance test. And don't forget, does it look any different in terms of our presentation of our graphs? No, it does not. So as I flip to the next page and do problem number 38, take a moment to read it. Okay, now as you have read this, we're talking about two different types of flowers and the lengths of those flowers. We've got the Caribbean red versus the Caribbean yellow. We've got raw data in which you're going to have to put it into your calculator. I didn't take the time because I'm rushing to get this done. We want to know, based on this printout that's going on right here, what information. So basically it's asking me to write a few sentences comparing the distribution. So what are we going to do, ladies and gentlemen? We're going to look at our socks. So here we can see some skewness for the red, but honestly the white looks pretty symmetric. The red one has a higher center because look at these values here on your x-axis, the numbers are going to be bigger. And the bottom line here for the yellow, it's going to be over here somewhere. Am I off a little? Maybe. But you'll be able to confirm. It paused. Don't know where it paused, so I'll just rewind. And I'm sorry. Okay, so as I was saying, we're going to have to look at our socks. Here we look at our red. We can see our red is slightly right skewed with everything being pushed from the right to the left. Well, our yellow looks kind of symmetric. Here we can see that the red has a bigger center just because look at where the yellow ends about there, but look at where all the red stuff is. So yeah, it's going to have a larger one. What is the true value? Or what, I shouldn't use the word true. What is the actual value of the center? Well, you're going to be getting in your calculator to figure it out in a minute. And we can see that the redness has a longer spread, so it has more variability. Don't see that there are any potential outliers, but when we do our box plot, we can confirm that one way or the other. We are about to construct a two-sample T interval for the difference of two mean, and in this particular situation of the variety of flowers. So you know we've got a four-step process, our conditions and assumptions. So here we've got it's going to be a 2 sample t interval. And here we're looking at the true values of mu sub 1, mu sub 2. And as you see right here, I have defined my variables. Next, as we look at our sin, they are 2 independent samples. And we have to look at our 10% rule. And in both cases, it is going to be applicable. You, like I said, are putting in the box plot because I don't have time to do it, but you're going to confirm with the box plot that there's no strong skewness, no outliers. So based on this information, we can use our T procedure. That's our second step. Remember, our third step is, here we are going to do the calculations. So our degree of freedom, so this is new, so please take note. Our degree of freedom, there's a couple of formulas we can use. We can use whatever the calculator spits out for us, or if we're going to use a table, which we're going to talk about tomorrow, we can look at the degree of freedom that is the smallest sample size minus 1. And the reason they do that is because that gives us a more conservative estimate. So we're kind of lowballing ourselves, but that is a good thing. Okay, let's notice our values that that the calculator gives us for our sample size, our mean and standard deviation. For the red, same thing for the yellow. And we're going to take that and plug this into the formula. Again, sorry for the speed, but I didn't have time to write out the naked formula. Let's check this out. We're going to discuss that tomorrow because my question is, where did that 2.145 come from? Did it come from a degree of freedom of 14, or did it come from the degree of freedom that the calculator gives us? That'll be part of our discussion tomorrow. Okay, and then after that, we do the math. Here's our confidence interval. So as we draw our conclusion, we are 95% confident that the true mean difference of the two types of flower, red and yellow, will be contained in this, or captured in this interval of 2.5, what is this, inches? Millimeters to 4.5 millimeters. And as I look at problem C and look at the final question right here, does the interval support it? Well, remember, we're trying to say that there's no difference. So we're looking at the idea that even though we're not doing a hypothesis test here, if it's no difference, it's the mu sub red minus the mu sub yellow equals 0. So if 0 is contained inside of that interval, we're okay. But it's not, so we are not, so it's not okay. So therefore, it does not support the researcher's belief. So I will see you guys tomorrow. We're going to look at you're going to show me tomorrow how this stuff looks in the calculator, and let's see how the degree of freedom pops up. I will see you guys later. Bye-bye.